questions from, I know there's a bunch out there, but anybody have a particular question or two, say from last night's assignment, this is your time to ask about? Chloe, start us off. 23? Sure, let's go take a look at question 23, everybody. All right, 23. Give me a second as that calculator's warming up for today. 23 is, I assume, on the next side. All right, 23. Oh, okay. 23, I like 23 a lot. All right. First off on 23, what's my keyword on 23, guys? Equilateral, yep. And on an equilateral triangle, what does that tell us? All sides are equal, which in this case is what? 12s, yep. Now, what does that also tell us? Equilateral implies what? Yep. All angles are congruent, implies all angles are 60s. And inside those 60s, when we drop down that altitude, what triangle is hiding right there? I swear. It's going to be a 30, 60, 90, okay? It's going to be a 30. What's that, Carter? Okay, 30, 60, 90. Now, what does that do also to that 12? Yep, it bisects it, correct. What are we actually trying to find? Find the length of the side of the, I thought it would say the length of the altitude. I did that all wrong, didn't I? That's not 12, is it? I said, no. My bad. That's why. I think I said the length of the altitude is 12. I wrote that down wrong. My bad. And the altitude is 12, not the sides are 12. My bad. So that's 12, isn't it? Okay, so here's what we got going. My bad. All right, so off that equilateral triangle, the altitude was 12, not the side. My bad. But it's still working out just fine. I like to draw that triangle off to the side. So it's just getting a little messy there. 30, 60, and 12. One more time. Go to our special right. Go to our reference triangle. I'm going to kind of start pulling that off that board. You should start kind of knowing it. All right. In our 30, 60, 90, what do we got? 12 is our what? Long leg. And what does our long leg represent? X root 3, right? You got to know those reference triangles, okay? So, on those reference triangles, that is the long leg of x root 3. Solve it out. All right? As we divide by root 3, that's what I've got going. Unfortunately, we have to rationalize. So, as we rationalize that denominator, that's where we get that, what? 12 root 3 over a perfect square of 3. And a lot of times we can reduce, right? 4 root 3. So I got 4 root 3, and that 4 root 3, remember, you got to remember what you just found out. On that 4 root 3, that x is always representing what? Short leg, thank you, Eric. Which is across from our, 30? And that 4 root 3 now, as I bring it back into our picture, that's, again, not our final answer, is it? That is half of the length of the equilateral. So that's why I doubled it. That's why I doubled it as 4 root 3, which is, not that, 8 root 3, okay? Which is then 8 root 3, 8 root 3, 8 root 3 all around, okay? I like that problem a lot, all right? So if I read that right the first time. Okay, keep going. Other questions that we got? Keep going. These are all good questions, all SAT related as well, on any given year. There's not a ton of geometry on the SAT, but these are definitely fair game ones. Brianna? 24. Length of to the near center of the diagonal of a square. So we got a square. The side lengths are 30. And with that, we were trying to find the diagonal. One more time. In every equilateral triangle, there's a 30, 60, 90 hiding. And in every square is what's always hiding. You kill me, Smalls. In every square, what's hiding? Thank you, and isosceles right. Oh, yeah. 45, 45. Every square has got 2 isosceles rights. Because, for a variety of reasons, it is congruent. Right triangle, there you go, legs. And that is diagonals and bisecting that. Give me 45, 45. So, in our reference triangle there. We got the what? The legs, right? 30 and 30. And what do we say? S root 2. 30, 30, and 30 root 2. Now the directions on this one does ask us to go to the nearest centimeter. So 30 root 2 to the calculator, and nearest centimeter, 42, 42. Okay, so 42 centimeters. That's nearest centimeter. All right. All right, keep going. Other things that we got. We're going to do more work with the special rights. It is going to happen now today, which is good with our transition to church as well. So now we're going to go with it. Anything else we've got? All good questions. Keep going, keep going, keep going. Once, and twice. We sold. Sold. Spencer said it before you walk it up. Make sure your name's on it. Luke, is your name on it? What? Yeah, okay. Just making sure there, Luke. Everybody, go get me the length of the two hypotenuses. Without hypotenuse, what do we got? AB is what? 2 root 2. Let me use the different color there. 2 root 2. Itty bitty hypotenuse is AD, which is? Okay, how many people use Pythagorean theorem? It's okay. It's definitely doable. How many people use our first special right? So let's not forget about that shortcut, right? Let's not forget about that. All right, now that we have those, we got those links, do me a favor. Go write those ratios, okay? Go write those ratios that I've identified here off to the side, okay? These ratios I've identified off to the side, I'd like you to go write them all together. Okay, I got AC based off of what we got. AE, what do we have here? 2 to 1. CBDE, what do we got?
2 to 1.
Okay, before you actually give me the reduced ratio, what did you have to start off with?
2 root 2 over 1.
2 root 2 over 1 root 2. Now, what does that reduce to?
2 to 1.
Because what happens to the root 2's?
Cancel.
They do cancel, which is 2 to 1. Cool. Now, let's flip it back actually to our book now. Now, don't do anything with that paper. We're going to keep using that paper for a few more questions. So give me a second to flip back to that page. Okay, so with that triangle there, okay, take a quick second with your partner. Question 2. Number 2, explain how you know those two triangles are what? Are similar. Give me a good explanation how you know that those two triangles are similar. How do you know those two triangles are similar? What shortcut did you use there? Why did you say angle similarity? Thank you. Angle similarity by sharing the two 45 degree angles. Absolutely. That's one of our shortcuts, right? What's another shortcut somebody I heard say? Eva?
SSS similarity because all sides have congruent ratios.
Okay, shortcut. You said side similar because all the sides. There's that. Now I'm going to clean up just a bit. All the sides are. Brianna was saying and Nevaeh was saying all the sides have the same ratio. So let's clean it up just a bit. Let's use that special math word. Sammy said a second ago. All the sides the same ratio. What was that? Proportional. Right. All the sides are proportional. Now, what was our other similarity shortcut? SAS similarity. Can we use SAS similarity in this one as well from what we found? Yeah, we could. Because what we did earlier was literally found everything, right? We had the 45. We have all the sides. We could use side angle side similarity as well. But at this point, you guys have already knocked it out with Jillian's AA similarity or Eva's SS similarity. As I walked around, you guys were solid off of that. Okay, so this is where we're going to then continue to make a bit of our pivot into some trig stuff, some of our trig ratios, okay? So as we stood at that 45-degree angle, okay, that 45-degree angle we're going to start calling here our reference angle, okay? Based off that, everything is going to be kind of built off that, how we define things. So standing at that 45-degree angle in that triangle of ours, we're going to call that our reference angle. So let's go into our picture there, and let's label that 45 degrees. Let's go and label that now our reference angle, okay? So go label that 45. We're going to label that our reference angle, okay? So it's all relative. It's going to be all relative to where you're going to be standing at in these triangles as we move into trig now, okay? Where you're standing, hypotenuse is a hypotenuse, right? What's the hypotenuse always opposite?
The biggest angle, right?
A little bit further. What's that, Brianna? Right. It's got to be, as you said, the biggest angle, correct? But it's got to be, what'd you say?
Right.
The right angle. Now, hypotenuse, absolutely. But after that, we got these two other ones that we're going to start talking about over the next few days, okay? The what? Opposite side and the adjacent side, which we've already started using some of that vocabulary way back when the first semester. We were talking about the relationship between the smallest angle is opposite the small side, like the medium angle is opposite the medium side, and that, which we've been already done talking about. The short leg is opposite the smallest angle, medium angle, 60 degrees is opposite the long leg. So here, this is what we want to start burning into our heads, okay? Standing at that reference angle, we have this opposite side we're going to talk about, the opposite side of that first leg, and then this adjacent side. So our reference angle is here. We got this new vocabulary word, we're going to call that the opposite side. And then the adjacent side is the other leg of that triangle. Now, adjacent is all relative, okay? As Eva's sitting here, who's Eva adjacent to? Eva is adjacent to Sydney, and right now she's adjacent to me, okay? It's all relative. But here, adjacent could also be considered the hypotenuse, but the hypotenuse takes precedent. Hypotenuse takes precedent because, as Brianna said, it's opposite the, 90-degree angle. So adjacent is that leg of that right triangle. Okay, so that's our new vocabulary for today. Let's start using that vocabulary here. Let's go up top here, back to our triangle a second ago. Okay, as we're standing that reference angle there, look at that big triangle that we labeled out, we were working on. At that angle A, we know our hypotenuse. Which of these then is considered our opposite side and which one is considered our adjacent side? 1 or 2? Which one's the opposite? And which one's the adjacent? There you go. Label that out, guys. You got that in mind, you're going to be solid. Okay? Let's flip. Let's go. Next page. Okay? So let's take that little half sheet that I gave you, and let's complete that table there, okay? Based off of that triangles that we just identified, what I'd like you to go through and do here with your buddy is complete that table, identifying the links that you found a few minutes ago, and I complete that table based off what you said did. So run it across. What's somebody got for that top row? Next one, run it across. All right, as I was walking through, some of you already started jumping down to the bottom one. Now, go ahead, fill it out. Some of you already had done it. Go, you and your buddy. Let's talk about just initially, what's that initial ratio? First one, ABC, first column, what we got? 2 over what?
2.
Okay, I'm thrilled with that first one. Let's just go right now with that. What's the next one?
2 over 2.
Okay. And what's the second one?
2 over 2.
What was that? Okay. 2 over 2, which is 1. Okay. Second one, ADE, what do we got?
1 over 2.
Okay, I saw them. 1 over root 2. Next one. All right, and last one. Cool. All right. That looked great. Again, Eva, a few minutes ago had asked, should we?
Rationalize it.
Thank you. So after that, as I was walking around, I saw a good chunk of you rationalizing correctly. Saw a couple of you almost there. Let's fix these out. So on that 2 root 2, let's pause and do a talk up to the side here. Okay, one more time. Rationalizing that denominator. All right. As we rationalize that denominator up in that numerator there, what do we got? We got ourselves what? 2 root 2 over, there's that perfect square, right? Perfect square of 2 square root of, yep. And what we get there, what is that? 4, right? So 2 root 2 over 4, and what's the last thing we can do? Yep, we can reduce that down to 1/2. Now I'm running out of room there, so I'm going to clear that out to just what? I saw then a bunch of you got correct then. Root 2 over 2, yes? I saw it on Eric. Eric had already reduced his down already to root 2 over 2, okay? Now, what do we get for that second one for a lot of you on the rationalized part? Same thing, thank you. Now, along the bottom, what you guys got on the bottom? Same thing, right? Root 2 over, yeah, root 2 over 2 and root 2 over 2, right? Okay, so off of that, these 3 ratios that you just found is our introduction to trig with you, okay? That's what we're going to start continuing to talk about tomorrow. Let's call these 3 things now our special ratios. Up at the top. This is our sine ratio. Do not call it a sin, okay? It's a sin to call it a sin, all right? Mr. Kirby here is one of our old math teachers here, all right?
Emphasis on old.
Okay? Don't call it sin. It says on your calculator is a sine ratio. Okay, sine. Next one here is going to be our, what's that? Cosine ratio. Okay, cos. But no, not cos. And then our last one here is going to be our tangent ratio. Get to know them. We've already said we've got 3 tools in our right triangle tool bag. What? Pythagorean theorem, our special rights going. Those are our 3 henna tattoos I keep telling you to get. We're going to add our 4th one here, right? A trig. So off of that, we're going to build on to that tomorrow here. But this sine ratio, okay, we're going to start talking about one of our good old mnemonic devices. Sine. Sine's coming from that S right here, opposite hypotenuse. Cosine. Cosine's coming from that C for cosine, A and H. Every math teacher you talk to, and everybody that's gone through geometry, T for tangent, and OA, TOA, uses SOHCAHTOA as a mnemonic device. So I don't know how many years it's been since I've had geometry. It's been a long time now. All right, shush even. Okay, but as I start saying, hey, remember that SOHCAHTOA here, it's just a nice little mnemonic device for us to say sine, opposite hypotenuse. Cosine, adjacent hypotenuse. Tangent, opposite adjacent. Okay, so you started that process of learning your trig ratios. Okay, all right, let's continue on here. Now, what do we have here? All these ratios, what? Turn out to be the same, right?
Yeah.
Okay, and as we talked about here off of that, why did those turn out to be the same? A few minutes ago, you said those triangles were what? Yeah, you said those triangles were, I guess it was on the previous page, wasn't it?
Yeah.
We said those triangles were what? Similar, right? So depending on what ratio you were looking at, right, those ratios turn out to be the same, right? So depending on which ratio you wanted, they were the same since they are what? Yep, they are similar. Now, on one of the, you guys, I think it might have been Sydney, I think, she said something about a reduction or enlargement, I think she had written on her paper. And it just depends on a perspective, right? However you kind of view those triangles from one to the other. It could be enlargement or reduction by a factor of 1 to 2 or 2 to 1 off that. We could have had triangles that were increased by 4, 5, or 3 2/3, whatever the case is. Okay, so just kind of depends on that perspective. But those ratios, yeah, should have been coming out to be the same depending on where you were looking at. Okay, that's our 45s, and we're gonna quickly get into a little bit of the 30/60s. So let's flip that. Let's see how far we can get into the 30/60s then. Okay. Now, on to the 30/60s then. Let's try to get into a little bit of work with that 30/60s. And on that 30/60s, I'm going to do that same thing here with you. Where on that 30/60 then, again, those two, the triangle here I'm working here with, yep. As you get that, I want you to measure out the short legs and the hypotenuses. The short legs and the hypotenuses on the 30/60s here. Short legs and the hypotenuses on this one here. Okay? Short legs and hypotenuses on this one. Right? Short legs and hypotenuses.
Oh, short
on
leg
this
and
one.
it helped if I listened. I was going for the long leg.
Short legs and hypotenuses. Go, go, go. You know the drill. Yep. I didn't get you one.
Sorry, you feel threatened about that. Me too.
Okay. Let's finish up here. Going across. What do we have here? What? 2
2 and 3.
and 4. Going across.
1, 3, and 2.
All right. Now, if you didn't get to the bottom table, let's try to finish this off here for the opposite. Opposite hypotenuse is what? 2 fourths. Adjacent hypotenuse is? Root 3 over what?
2 root 3.
2 root 3. Yeah, sorry. I was.
Okay.
Yep. And then last one, adjacent over opposite over adjacent. 2 over 2 root 3. Okay, bottom row. One more time. 1 over 2. Root 3 to 2. And 1 over root 3. This is, again, my sine, cosine, and tangent. Get to know them. Okay, those are my sine, cosine, tangent ratios. And that's where we're going to pause.